3.5, solving nonlinear systems. That means basically finding the intersection points between a system of two equations. In this section, we're going to be looking at solving them by substitution. So when you have a system of equations where you have quadratics and linear equations, notice quadratics are parabolas in this case, and the linear functions are lines. So when you have these graphs, you have parabolas and lines, or parabolas and parabolas, such as this case. But notice the intersection points. You can have two intersection points, you can have one intersection point, you can have no intersection points. So it really depends upon the problem. Now, when you look at this problem, and it says solve by substitution, you have two equations. I don't like the idea of solving for x, although maybe that makes sense to you. What I would prefer is to solve for y and get negative x plus 4, and then just substitute that in for your y, so you don't have to use the FOIL. So then it would be x squared plus x minus, in parentheses, big parentheses here to remember to distribute the negative sign through. And then you'd have something like this, and combine like terms, add 1 to both sides, and now you would factor. Factoring looks like this. 3x minus x is 2x. So your two answers are x is equal to a negative 3 by setting this equal to 0, and setting this equal to 0, x is equal to 1. So you're going to have two answers here. X is negative 3, x is 1, and by plugging those in for the easiest equation, either one would work, but the easiest equation is, let's see, negative 3, so y is equal to 7, and 1, y is equal to 3. 2 points of intersection when you're looking at graphing a quadratic and a line. Now, I worked these problems out ahead of time because there's a lot of work, but the main step, which is the first step, is important to talk about. When you have y equals and a y equals equation, both of these y's are equal to each other. So what I did is I basically substituted this right here in for this y and made an equation. Or you could think about it as taking this and substituting it for this y. So I eliminated the y's, and then I solved for the x's by factoring, and so the point is going to be 2, 0. Notice when you factor, you get a binomial squared. That gives you one answer, and so the intersection is 1 point. Solving this, they can get tricky, and this is the case where they do. I look for, first of all, the line, and what can I solve easiest? I can solve for this y the easiest, so I subtracted 2x from both sides, and then I took my y and substituted this part for y into this y to get rid of the y. Once I did that, I solved for x, and I found out that, you know what, I can't factor that. I've got to use the quadratic formula. So when you use the quadratic formula, in fact, good idea at this point is to figure out, well, what's my b, or my discriminant. My discriminant is b squared minus 4ac, because I just want to see if there are any real solutions. By doing that, I see that I'm going to have 1 squared minus 4 times 1 times 5. 4 times 1 times 5 is going to be equal to 20, so 1 minus 20 is negative 19. No real solutions. There is no intersection between that parabola and that line. Looking at the third case, again, what is the easiest one to solve for? That y. Subtract x squared on both sides. I then substituted in for this y. Be very careful on the way you write that. That negative has to be distributed to both terms. And then I collected both terms because when you add 2 to both sides, you get 0. Factor out an x, which means you have two answers. This can be 0 or that can be 0. And then you plug those numbers, x's, back into the easiest equation to get your y's, and then you have the two intersection points. So solving a system of equations where you have a linear and a nonlinear equation.